If you notice in the volume source node, we have this activation parameter here, and basically what that does is turn off or on this, the emitter, right? So if you take a look close, you can see it just disappear like that. And the reason they have this slider or this parameter window instead of just a checkbox is that we can now animate this parameter. So what I'd like to do is offset these, so one starts flowing first and then the next one and then one after. Whoops, space H to home that. So what I'm going to do, is type a little expression in here so that we have something a bit more interesting. So if we use $F, oops, is that typing? So $F is more than, and we'll do 25 here. So just to check that that's working, if we come down here and click on the brain, it will turn off the solver, so it's not actually doing anything, but we'll see this number change. So this basically is like a shorthand for an if statement, an if expression. So it's saying if the frame number, current frame number is 1, is more than 25, then yes, which is 1. And if we click on here, we'll see the result, which is 0. So it won't emit at this point until the frame number here is 19, 22, and then as soon as I go over 26, I get 1. So it's a nice, easy way of animating without having to put in keyframes. Okay, so we'll have 25 there, and the next one we'll do 50. So $F is more than 50. Cool. And then this one we'll leave to start at the beginning. If I go back to the start, I'll raise the particle separation just momentarily, just so we can see what's going on. Just get a quick sim and have a look to make sure this is working. You can see now that I've only got one emitter. So let's play through that and just make sure that we get that working. There we go, frame 25. And the last one at frame 50, there it goes. Okay, perfect. So it's a bit more interesting there, be a bit more dramatic in terms of the effect. So, right, so I think now we can go ahead and do a really high resolution version of this. So I'm going to put this back to the beginning. I'm going to drop this to 0015. Okay, so that we get a lot more points coming through. You can see that there. And okay, we need to import all of this from DOPS and into the SOP land. So I'm going to create another geo folder. I'll put it up here, call it fluid. Let's dive inside, and then we'll take a .io. So all of these are for fetching information from DOPS. I'm going to use .io so that I can cache the information. I'm going to do 100 frames, so I'm going to change this frame range to 100. Apply. There we go. And then here we need to find our DOP network. So we go into OBJ and the sim, grab that. Still nothing yet because we need the DOP node. And we go to, so in the sim, and then find the flip object, right? It's typically called something object with particles. I think it's pop object with bullets, I think it's packed bullet object or something like that. It's always the same thing. You need the DOP network and then the something object. But still we don't see anything. We need to just come here to fields and click plus, and there we go. We've got our particles. So as we've got a lot more resolution now, we've got lots more particles coming in. We need to, I'm going to run a cache of this. So here we've got the correct frame range because I just changed the frame range down here. So we need to give it a good destination. Let's see if I go into there, go into my HIP folder, and let's create a geo, you should have one already, or sim folder, sorry. And let's call it Jock version 1, and we'll call it, and then we need a $F3, as we've got we got 100 frames, so we need as many, if it's under 100 you only need 2, so it gives you a padding of 3 digits. And then I will do the geo, which is the Houdini's native file format. Okay, that should be fine. Click accept, save to disk. We'll see how that comes out. So that sim has finished. It did take about 1 hour and 45 minutes. On my computer, it could take longer or less time depending on what you've got. Let's go to the last frame so we can take a look at the form. It looks quite nice. And also if we take a look at the information, we can see we got 16 million points, so quite a lot. But because of that, because of all those points, we'll be able to bring out all this detail. We'll get a lot more detail in our mesh and a much better result.